RCDC can design and detail beams, columns, shear walls, open footings and slabs. It can link to a STAD or an ETABS file. As long as the analysis is done either of these analysis engines, the software can import the analysis output, be it forces, member sizes, etc., and take it through to design, detailing, drawing, documentation, quantification, the entire stretch. To start a new file, we go to file and say start a new file, and we enter the basic project details. So I can say call this a sample project. Client is, let's say, we ourselves, and engineer is, say, Sajid. We can then decide whether we want to work with an ETABS file or a STAD file. Let's say we're working with a STAD file. I can just go and select the .std file in itself. So I go and pick the .std file. I say open. The software goes and starts reading the .std file. So the first information it seeks from us as a user is what is the element that we wish to design. Are we designing footings, columns and walls, beams or slabs? Let's say we start with columns and walls. That's being generally the primary element that we start working with anyways. I select columns and walls and say OK. Now the software will go into STAD, read all the information and also understand and interpret the information to create logical data for design. So just take a moment, all the information has been read and the input screen is in front of us. What we see in this input screen is primarily two parts. On the left there are some data tabs. There are three tabs, one called column reference, another called column size and the third called the level data. And on the right we see a layout which gives us the column layout. Now this column layout will obviously match exactly with the STAD file. So if I go and check here, this is my sample STAD file, and if I go into the plan view, this is the plan view in STAD, and this is the view that we see in RCDC, which is obviously translating that entire plan into the RCDC environment. Another thing that the software tends to do is when we work in, especially with STAD, we do not have alphanumeric column numbers nor alphanumeric information for levels. They're all numbers in itself or Y coordinates for levels. What RCDC does is tries to make it more practical and gives it a column number. So what it will do is pick up the columns from top to bottom, left and left to right, and give it an alphanumeric numbering. So for example, if I zoom here, you'll find that this column is called C1, the next is C2 and C3 and so on. And the last column in the will be this. Now this is an initial numbering that the software has defined, left to right, top to bottom convention. The user has the freedom to change this column marking if he wishes to. What the software also does is, if we take this corner column, identifies that which are the members at different levels which actually constitute that column. So for example, if I go to this tab called column reference, you can see that C1 is highlighted here because it's been selected in the graphical window. It is telling us that C1 at different levels is represented by these members. So member number 1, 11, 21 and 31. To explain what I mean, if I go back to the STAD file and we go to a 3D view and look for beam numbers, you will find that this column, the column that we are talking about, is comprising of members number 1, 11, 21 and 31. So this identification of vertical design continuum or the geometry is something that RCDC does and understands. So even if there is a slight offset in modeling, etc., RCDC can understand all those continuum from STAD in itself. So you can see all for each and every column it is given as the various member numbers. And if we scroll down, you'll find that some column, for example, let's say C11, you can find that the member numbers are provided only at 2 levels. Now this is because the building is such that the columns actually stop. So you will find that the columns at this part have actually stopped and it doesn't go beyond it. So that is exactly why you can see only members at 2 levels. And if I go to the third level, you'll find the plan itself changes in the layout tab. So it tells us that 2 columns have actually stopped and only the remaining columns are continuing. So the software has a capability to identify any type of column. So columns from bottom to top, columns stopping at some levels, columns floating from some levels. As long as it is modeled correctly in the geometry, it can be picked up and read by the software. The other information that is provided is a tab called column size. This is an information tab where what is provided to the user is what are the sizes of the members at various levels that has been read from analysis. So this is just a method of cross-checking the the column information in itself, what has been read from your STAD file. The third tab is quite significant. It is called level data. It defines the various levels that's been identified from the STAD file. So what we are seeing here are 4.2, 7.8, 12.05, etc. the various Y coordinates that are available in the STAD file. And what the user can do actually here is multiple things. One, he can give it logical story descriptions in itself. So I can change 4.2 and let's say I can call it plinth. I can call this first. I can call this second. I can call this terrace. So I can give logical names which might be taken from an architectural plan so that the drawings and the reports that are generated are generated as per this description. So it will give me plane first, second, and not the y coordinates from STAD. What we can also do here is set the vertical design environment. So we can define the material property, that is concrete grade, steel grade, and cover, that will be applicable for various levels for design. So let's say I want to design with M40, so I can come and apply M40 and apply it to all levels. I say design with M40 FE415. So this is the basic design parameter that I am defining. So for each level we can, if required, sometimes material properties might change. So higher grade of concrete at the base and reducing as we go towards the top. So you can simulate that by just providing the corresponding material property at different levels. Another feature that RCDC allows the user to do is the ability to group members and the ability to group columns in plan. So suppose I have a tall building, say 25-30 story building, and I want to group across levels. So I want to design a common cross section from foundation to third floor. So I want to take the worst case from foundation to plinth, plinth to first to second, and so on. That is grouping across levels. To do that, we have to tell the software to group some levels. So for example, I can just come here, select these two levels and say group levels. When I say group levels, you will find that the group number is same and the color has changed to be the same. So now what will happen is, for each level, the software will design the members at both the levels and take the worst case scenario, and that will be the relative cross section for that. So you can group any number of levels, could be 1 to 5 to 10, it is immaterial. At all points in time, software will take the worst case scenario and work with it. Similarly, we can also group columns. I'll show you that also, but before that I'd like to mention that the RCDC gives us the flexibility of grouping columns either prior to design, that is before taking a look at the preliminary design output, but deciding that I want to go this way anyways, or designing without grouping, looking at the design output and then say, okay, in the post design environment I would like to group levels now based on the preliminary design that I'm looking at. So you can design group pre-design or group post-design. So let's say I want to group post-design so that I can show you what actually happens, and we always recommend that we should design post looking at the actual output. So I can just come and say that remove from the group. So you'll find that they go back to being different groups in itself. So each level is going to get designed individually. Similarly, we can also group columns. So if I want to group columns, I can go to this tab which says group ungrouped columns. I can select one or multiple columns, I can create a group. I say OK. Now if I scroll here, you will find that these two columns have the same color, indicating that they have been grouped. So at each level, at plane it will take the worst case of C1 and C2, at first it will take worst case of C2, C1 and C2, and so on. So you can group in plan and you can group across levels, both of it. Proceeding further to design, we can make a host of design settings. So I can go into, there are multiple tabs. So one is a general design setting window, where we can set the basic design environment. So we can decide whether we want to design for ductility, do we want to apply live load reduction, are the columns braced, do we want an optimized design or a quick run unoptimized design, what are the effective length factor, definition of shear wall, how do you want to enforce the minimum extremity check, so simultaneously one axis at a time, or some engineers want to ignore it in itself, so you can have the option of saying ignore this check. So various options are available to the user. You can then go into reinforcement settings and set a host of detailing parameters. So we can set minimum and maximum percentage steel separately for columns and walls. We can set minimum maximum longitudinal bar spacing. We can also set the preferred bar spacing for equispaced and zonal arrangement. Now the preferred bar spacing is important because when the software designs columns or walls, it does so from first principles. That is, the interaction charts are generated for a given arrangement of bars from the first principle. So we really don't pick up directly the codal charts, but we generate charts for the given arrangement. And for that, the bar arrangement is very essential, and that comes from this user defined input of the preferred bar spacing. So based on the preferred bar spacing, the software will determine how many bars can be there in a given section and then find out the interaction data for that arrangement of bars. So it's a very first principle based approach to design. Nothing is left to chance, as accurate as it can possibly be. The other information that you can set is the detailing environment. So you can decide what are your available diameters. You can set minimum maximum diameters for columns, for walls, for links, etc. Minimum maximum bar spacing. See, all possible design and detailing parameters can be controlled by the user. And the other thing that you can see is the generally accepted normal norms are already programmed in. So you actually, the form opens with all that information built in. So you come and edit by exception. So wherever you want to take a deviation for a given project, you can come in and change that and say, okay, for this project I want a slightly different arrangement, etc. So you can make that setting from project to project and not necessarily have to come in and edit at all points in time. Now before we go into design, I'd just like to show you this graphical window itself that you are seeing, the UI is very dynamic. You have the option of viewing multiple data at different points in time. For example, currently we are seeing two tabs, one is a table and one is a graphic. Let's say I just want to see the graphic in itself, so I can just come and merge these windows here and say, okay, let me see only the graphic. So I have a normal graphical window like an AutoCAD where I can zoom, pan, etc. and zero in on any member, so that information is available. Or if I want to see multiple windows, so I can, let's say, take column reference and say I don't want to see it, I want to see it at the bottom, so I can arrange it at the bottom. I can take any other table and say I want to put this at the right, and let's say I take another table and say I want to put it here at the bottom. So in effect I can see 4 windows and then resize each windows depending on whatever is the information I am doing, so I can increase or decrease the size so that information is available to me. So it's a very, very dynamic window where the user can decide how much and what information he wants to view depending upon what activity he is doing. So it gives him total freedom and flexibility. We'll just merge this back. There you are. We just merge this back and go back to the original. So I can just put this here and go to as we began with. So it's a very dynamic UI. You can decide what you want to view, move these tabs and windows as the way you would wish to. Now once this information is ready, we can go into design. So I just come and click on this button, this is auto design, and when I design that, the first step that I need to do is to decide what is the load cases that I want to work with. So what you can see in this window here is the load cases from your analysis, and the software is prompting you to define what is their types. So I can say this is of a type dead, this is live. So even if you have not defined in so detail in your analysis file, you can still come in and define for the software to understand that these are my load types or different types. I can accept this. So my primary load cases are defined. I can say okay, and now I go into definition of combinations. Now RCDC is a very dynamic software. The user has the freedom of importing combinations directly from analysis. So if he is defined in his analysis file, he can directly import those load combinations, or he has the freedom of using combinations from a very large template that is already built in. So there is a large template of all the normally accepted load combinations that are built in. So we can just scroll down these templates. You can find all possible load combinations are built in. Also you can edit the template if you wish to. So I can go to edit template. I can add a combination. I can remove. I can edit. So a user can personalize load combinations from a project to project. So you can either add from a template, or you can add from analysis, or you can use a combination. So some load combinations can come in from analysis and some can come in from the template. So I can just go and say add from analysis. So all the combinations that were defined in my analysis file are displayed to the user here. Also among these, if I don't want to design for some, I can come and remove them. So I say I don't want to design for these two. I can ignore the forces for these two combinations and work with it. So it's very flexible and gives total freedom for the user to decide his design environment. Once I've defined the load combinations and basic load cases, I say OK. The software will now create the combinations based on the combination definition, design all the columns up to bar arrangement. So it will optimize, perhaps give a combination of diameters, etc. and do that all for all the columns in a matter of seconds. So I think we have got around 25-30 columns here over 4 levels. So all the columns are designed and a basic design output is displayed to the user. So if you just scroll down, you can find that we go from C1 to C31, so there are 31 columns. All of them have been designed. If you look at the output in a nutshell, you can find that there are some bands. There are some white colors rows and some gray color rows. Basically white color and gray color, just the separation between one column and the other. So what you can see right at the top here is first for column number C1 and C2, because we had grouped those columns prior to design. So we are getting a design which is for the worst case of both of those. Design is presented for each level. So first level, second level, third level, fourth level. So all the levels are defined, and also the names that we have changed now are what are displayed here. So plinth, first, second, terrace, etc. Then you can see the size, the material property that have been designed for what has been, it is a column or a wall, what is the percentage steel provided, what is the main reinforcement suggested, what are the links suggested, and what are the ductile reinforcements suggested. So the basic design information itself is provided here, and you can see as you scroll down that for some of the columns there are combination of diameters. So this is 16 and 12, 20 and 16. So design happens from section to section based on the requirement of that particular section. Now what is different in RCDC actually starts from here on. I mean, till here we've just done imported data from analysis, done a basic design and presented the output. Now this is something which any other software would also do. But the power here is the user has the total freedom to edit this detailing in any way he wishes to. So you can go and change the design, so you can change material properties, you can change sizes, or you can change just the detailing. So you can redesign and rework in any way you wish to. There are multiple tools available for doing the same. I'll quickly take you through some of them. Let's say I want to redesign this particular cross section. So I select that cross section, so C1 and C2 at the first level. I left click and I say redesign the local column. So I'm designing that particular cross section. When I do that, this window opens up where you can see obviously the column drawn to scale and with the bars currently provided. So there are 12 bars, 20 numbers. So you can see those are provided here. On the left, you can see all the other information. So what is the shape of the column, the size, the bar arrangement, the design parameters, the unsupported length, etc., the number of bars. So the user can come and edit any of these things. For example, I can change the number of bars from 4 to 3. And you'll find the drawing changes. Obviously, it reflects the changes that you want to, and you can have a different design arrangement. Or I can say revert to say I want 4 bars. Or if I wish to, I can go in and change the material property, grade of steel, define a different cover, or change the size of the column in itself. So practically every parameter of design can be altered by the user. He can also suggest some other bar arrangement. For example, what you are seeing here is the default wherein the bars are peripherally arranged. Now let's say we want to add some bars within the section. Sometimes some people do that, especially in square columns. So if I want to add a bar, I have the freedom of adding a bar. So we use these tools available here on the right end. There are multiple tools. One which says add a bar, one which says change bar diameters, etc. We can use these tools. I'll just display. If I want to add a bar, I come and click and say add a bar. I come to the location that I want and I click, and 4 bars get added. The symmetry is always taken care of. So when you click at one location, by symmetry, 4 bars are added to the entire column section. So you can see there are 4 bars are added. The added bars also are color. Now color coding is basically displaying different diameters and different colors so that it is very easy for the user to perceive them. The template is provided here. So for example, 12 is green in color, 16 is brown, 20 is yellow, and so on. So you can currently see that all the bars are green in color, indicating they're all 12 dia. Now if I want to change the diameter of any bar, I can do so also graphically. So I can come and say change the bar diameter, select the diameter that I want to apply, and I go and select the bar. So when I select the bar, I can see all the 4 corner columns have become yellow in color. So I am basically defining a totally new bar arrangement in itself. So all of them have changed. When I have suggested this different bar arrangement, the AST provided and the PT provided have also got augmented. So you can see the AST has increased, so the PT. So as the bars diameters and have been changed and new bars have been added, and everything has got updated in the section in itself. Now once we suggest a totally new arrangement to the column, we need to check if it is sufficient or otherwise. It could be possible that it is not sufficient. So for that we need to redesign the column with this arrangement that we specified. It could be only change in bar arrangement or material property or size, any edit that we've made. So we come to the left here and there's this button which says redesign. I click on that. It will try to design the column. In case the column has got successfully designed, you will find that it will gray out this entire area. Provide this reinforcement here in 420 plus 212, what is the design reinforcement, and give you the section capacity of the current section in itself. So it is checked these RSS, the efficacy of the current arrangement. If it is sufficient enough, it has said okay, the design is safe. Now if I want to further edit this, I want to change something else in itself, I can come in and click on this unlock button and edit it further. Well, let's say what we've done currently is suggested a new arrangement, that is location of bars and some diameter options. Now let's say I want to give only arrangement of bars to the software. Say I want bars in these locations or number of bars, and I want the software to suggest the best possible diameters. If I wish to do that, I can go here and there's a button which says clear the diameters. When I click on that, all the diameters are gone. They're all white in color. The area steel and percentage steel both are 0. So I am not suggesting any diameters to the software. And now when I redesign, it will take bars in those locations and provide the best fit diameter options. So it is redesigned and now it is suggesting it all of 12. So 24 of 12 dia are sufficient to design the column. So in this way you have got multiple detailing options that are available. So you can design and change detailing, design and change bar sizes, column size, bar arrangements, material property, all of it. Once I am satisfied, I can just accept it and the arrangement gets reflected here. Now to take the editing forward, once we've edited one section, in case we want to reflect the same editing in multiple other sections, The other one option is to go to the other section and follow the same option saying redesign local column and make a similar change. The other thing is I can do a faster thing of just copying the reinforcement, coming to another destination and pasting the reinforcement. Now you find that that reinforcement is also changed to 24 to E12. Now it looks very simple, however it's not just a simple arithmetic copy paste, it is an engineering copy paste. So when I'm copying a set of rebars and I apply it to a different section, the software actually checks the sufficiency of that provided reinforcement. In case it is sufficient, it will allow the copy and paste, else it will reject it. So for example, if I try to paste the reinforcement in another section, say here, where I think it will fail, and we say paste the reinforcement, you will find that it comes and returns an error, and if I go here, it says this section fails with revised reinforcement. So it checks for the sufficiency at all points in time. So it's a properly engineered copy paste, it's not a blind copy paste. Now going to another method of detailing, what we've done is we provided 24 bars at the lower levels and currently 20 bars at the higher levels. Let's say we want to provide 24 bars in similar arrangement at the higher levels also, but since 20 of 12 failed here, I want the software to suggest to me what is the best arrangement of 24 bars that will suffice for that section. Now to do that, there's another quick tool wherein I can just go in and say copy the bar arrangement, where only the location of bars within the section are copied. I can copy one or multiple section and I say paste the bar redesign with the selected bar arrangement. When I do that, the software will redesign those two sections with 24 bars and design the most optimum. So for the first level, it is 24 suggested 24 T12, which is sufficient. For the higher level, it has suggested a different arrangement because the reinforcement requirement is larger. So here if I go and now say redesign, you'll actually see the cross section provided. So you'll find that at the corner it's provided larger reinforcement, 16 dia, and at the center 12 dia. So it is optimized and provided a very tight arrangement with 24 bars. So in this way, by using these three tools, you can edit any cross section at a micro detail and apply those changes across multiple sections. For copy and paste to work, the only writer required is that the size of the column should be the same. As long as the size of the column is same, the same arrangement can be tested and see if it works. There are a couple of more quick detailing options which help you detail at a macro level. Currently we've done micro at a bar or a column level. Let's say we look at a column here, C3, and we want to redesign at all levels from bottom to top. So make some macro change at all levels. So we can come in and say redesign the entire column. So when I do that, you will find that you get a window here where the column is displayed at all levels. And now we can make some changes at all levels. For example, let's say we are making a change in the column size from 600 to 600. And whichever levels we are making a change, you also find the color has changed in the background. And now we come in and say redesign. So those columns will get redesigned with the revised properties. Now the sizes were changed here. And you will find that percentage steel, reinforcement, etc. are displayed in this window in itself. If I just move this window aside, you will find that the original design is still available to us at the back end. So though we are making an edit, the edit does not replace the existing design. So whenever we are editing, the software gives us three possible lines of action. One is to view the output and then decide to accept it. So if I am comfortable with this, I can come and accept it. If I am not comfortable, I can cancel it and I can go back to the existing design. So I don't need to override that. Or the third is if I want to continue to fine tune, I can unlock and continue to fine tune and say perhaps make a change in some other parameter or whatever. So whenever you make an edit, you have an option of either accepting, rejecting or continuing to process it. But default value or the original design does not get overwritten unless the user says so. So now I say accept and you will find that for C3 the columns sizes have changed to 600 by 600. So that variation is built in at all levels. A parallel or a complementary editing tool available is to design all columns at a given level. So I can come and say redesign entire level. So in case let's say I can select one or multiple levels and say I'm selecting terrace level and I want to change some of the common properties. So let's say I want to, instead of designing with M40, now I want to come and design with M30. So I want to design with M30 and I say redesign. So here it will design all the columns at that level with M30, provide a one-line design of all the columns. So you can see there's a one-line design of all the columns at that level. So you can look at the efficacy of your change. If you are comfortable, you can accept it or reject it as before. So whenever you make a change, once more you can see the impact of the change. Let's say we are comfortable with M30. We say accept and you'll find that everywhere the grade of steel has changed to M30, grade of concrete has changed to M30 for at that level. Now this was editing the longitudinal reinforcement. Let's say we also want to, and the software allows you to define arrangement of links or the horizontal reinforcement. So I can go in and say edit the link arrangement. When we do so, this window opens up where on the left you can see that each of the column is arranged by size and also by number of bars. So for example, for 700 by 700 there are two entries. One is with 24 bars and one is just 20 bars, because the link arrangement could vary for any of these. So it will group all the columns by their size and number of bars, and then you can edit the link arrangement. Let's say I come in and select this arrangement, which is 700 by 700 24 bars. What you can see on the screen at the right is the default or system defined link arrangement. If I bring my mouse over any of the bars, you can see that the link gets red. So you actually understand what is the current linking. So I got these hoops and perhaps I got a master link, etc. Now to edit it, one, I can just erase all these links and start from scratch. To do that, I come to this reset button or clear links button. I click on this, all the links are gone and I can only see the bars. Now to define my own link arrangement, I have four possible options. One is a master link, which will give me a link across the periphery. A link over 4 bars, so any 4 pivotal bars, it could be any shape, rectangular, trapezoidal, doesn't matter, as long as there are 4 pivotal bars. A link over 3 bars, again 3 pivotal bars, and a open link or a link over 2 bars. How do we link? Very, very simple. Let's just see. If I want a master link, I come and click here. It gives me a master link by default. If I want a rectangular link or a 4-sided link, I select that and I just do a window select of the bars. I not only get a link around that, but by symmetry I get 4 links on each side. Simply I can come and select a horizontal link here and I can select a horizontal link here. So this closes my horizontal link arrangement. To push it forward, let's say we want to do something non-standard, I can say I want a triangular link from here and I select these 2 bars, I get a triangular link. If I want an open link, I can select bar 1, bar 2, I can say bar 1, bar 2 by here too, and I get a totally different link arrangement. So as simple as that, just by clicking a few buttons, you can actually graphically define your own link arrangement. And the beauty is the edit that you have done here will get reflected in your drawings and your quantities, etc. So whatever changes that you're making here will get reflected all the way down to all the other outputs that are there for the same column. Now let's say I just accept it and I move out, and then we can go into the reports to see if these changes have really got affected. So this was the various detailing and designing or redesigning option that the software gives, where you can control your entire design output to a micro level. Now let's say we want to view the various outputs. Let's say I go into reports and there are multiple outputs. There are 2 drawing outputs, text and detail schedules, and there are multiple text outputs which help you present data to an external environment and also for us to understand the entire design process much better. I'll take you through serially one by one all of it. Let's say we want a text schedule. I just come and click and say give me a text schedule. So the software will create a CAD drawing of the entire columns in a text format. There you are. As simple as that. I just zoom in here. You'll find that for each column, if they are grouped, it will give you the group number, and each level, so 0 to plain, plain to first to second, etc., which we had defined in the during the design process. For each column, it will give me size, the steel, the links, the material, the special confining zone, and so on. So all that information for all of it is present at a touch of a button. You can find that the entire drawing has taken hardly a matter of seconds, and it will exactly reflect what we have done in our design. To save this drawing, we can just come in and save, click on the save button. It will create a DXF drawing. The DXF drawing can be opened in any CAD platform, and then if you wish to, you can further edit it or send it to site directly as you deem necessary. Now this is a detailed section. If I also want to see the link arrangement and the details, etc., I say give me a detailed schedule. I can select the levels, the start and the end levels for which I want to present the output, and also where I want to present for a few columns or for all the columns. Let's say here we say give me for all columns. I just click OK. So it will take a couple of seconds or at max around 30 seconds to generate the entire output. It's generating the output, and now it's just about writing or creating that graphical drawing output. So here you will see all the columns drawn to their cross section, the link arrangement, a copy of the link arrangement showing exactly the layers of links, etc. There you are. So the entire drawing has been generated in hardly 1 minute. All columns at all levels, exactly as the way we have designed. So if I come and say zoom in on this, you'll actually find that this is the non-standard link arrangement that we actually done when we were detailing. So you can find all the bars, the detailing, And if I pan down, you can actually see the actual arrangement of links. So the master link, the four corner links, the triangular links, the cross links, everything are displayed in this. So a copy of it, all the other defining factors. So what are the material properties, special confining zone, the links in the special confining area, the normal links, and also each bar is drawn to a given code. So every diameter is represented differently. So for example, here I think this is 12, and if we go to some other column, we can see different diameters also. I'll just, if we zoom in here, so we can see 16 looks different. So at all points in each bar is drawn to a different notation, and that notation is mentioned next to the, at all points in time you can say this is a 16 and this is a 12 dia bar, etc. So all that information is available to the user. Very detailed drawing with layers, colors, text styles, dimension styles all built in, and everything that as a user you can also set for yourself. So I'll show that to you later, how you can create your own drawing styles and text styles, etc. So this is the column detailed drawing. Now we can move to the various text reports. If I want a summary, I come and click on a summary, which is a quick, small tabular output of each column. So it gives me load combination levels, etc. And therefore each column at each level, material properties, PM, XMY, percentage steel, main steel links, etc. All that information is provided from top to bottom. This is a design summary. This is for basically for internal checking, etc. It's an instrument that can be used for that. Or we can create a detailed design calculation report. If I go into design calculations, and I can suggest select one or multiple columns. So I can say C1 at this level. I say OK. It gives me a verbose detailed report with short forms, codal references, and everything. So load data, analysis data from right from analysis, minimum extremity check, slenderness check, total design calculation moments, biaxial design check, interaction ratio, design for shear, design of links, design of special confining links, and finally a table which collates that entire link design information. So very, very detailed and verbose output. This output can be printed directly from RCDC in itself, or you can save it as an HTML file, open in any editor, could be a browser or Excel or Word, and you can then personalize it. None of the drawings or detailed calculations are branded by us. You will not find our name or logo anywhere in any of these reports. You can personalize them, brand them, and submit it to the required authorities. Moving further, it's another interesting report called design data for all load combinations. For example, if I go to the same column C1 and C2 at this level, and I go to the outputs, what this report gives us is a single line design of all the load combinations. So if there are multiple load combinations for which the columnar design will give you information for all. So for each load combination it will give you P and MX from MY for analysis, minimum eccentricity moments, slenderness moments, the net design moment, and interaction ratio for that load combination for compression and axial force design, and tensile steel ratio if in any combination there is tension in the column. So this gives you a flavor of the design of the column across multiple load combinations. So you will see that a lot of them are very close. So there is something which is 0.58 here, 0.65, 0.55. So all of these are very close, higher interaction ratio ranges, which would govern the design of a column. And this information is sometimes sought by proof consultants to prove that you have designed for all load combination. So this information can be sent to them. There's some 0.73, 0.72. So it gives you the entire great detailed design output. The next report that gives us is something is known as a percentage snapshot. Now this is something that a lot of senior engineers and we tend to use to get a first cut feel of the design. So what this report gives us is for each column at each level just the size and percentage steel. So when we are looking at the efficacy of the design, whether it is as per our expectations or not, we might not want to actually look into all the details but understand at a percentage view. So this gives me a percentage view. So for each column you'll find that at each locations give me size and percentage steel. Another thing it does is it sorts all the columns by the size. So columns of similar size are next to each other, and then you can use this report to decide if you want to group. So for example, if I'm looking at C11 and C18 and deciding whether I want to group them, you see that the variation, the percentage steel is the same at the lower level. At the higher level there is a slight variation, and I can then based on this say okay I want to group, or say no, the variation is too much, I don't want to group. So there is information based on which the user can decide if he wants to group or otherwise. So the percentage snapshot, apart from giving you a snapshot at the percentage steel level, also gives you information to decide whether you want to group columns or otherwise. Moving to the next report, there is an interesting report called column sizes changed. What this does is, it gives you a list of all the columns whose sizes during design have been altered from their original material property. So for example, what you can see here is column C3, which is represented by member number 201, 211, etc. at various levels in your analysis. The original size was 700 by 700 and the modified is 600 by 600. So in case you wish to go back to your analysis and reflect the change, you can use this report, zero in on those members as is defined very clearly here, and go and make the necessary change and perhaps reanalyze and come back or compare the outputs if you wish to. So it gives you a very detailed output giving you what are the members whose sizes have changed and what is the implication of the same. And finally, there's another report called a design failure report. If I go into that, currently unfortunately no columns have failed, but in case any columns have failed, this report will give us an information of which column has failed for what reason. So has it failed in compression, in tension, in flexure, in shear? So depending on the type of failure, the user can actually take corrective action. So it lists all the failure cases and helps you understand the failure, why they have failed. And finally, you get a bill of quantities. The software gives 3 different bill of quantities at great level of details. So it gives you a BOQ summary, a detailed reinforcement type-wise report, that is how much is vertical reinforcement, how much is horizontal reinforcement and so on. And finally, a level-wise and diameter-wise report. So for different purposes, the summary can be used at a macro level to understand at a management level, a reinforcement type-wise at an engineer level to understand which component of reinforcement is contributing to bulk for the consumption. And finally, a procurement manager's report which gives me level-wise and dia-wise output. Finally, I go into define rates because the summary will also give me some costs. So if I wish to do that, I can go into define rates and define the rates that are prevalent in my market. I can also provide a plan area because the software will also give me some basic design metrics. So let's say I provided the information, I go to reports, I say give me a BOQ summary. I define how I want to lap, I say OK. The output is displayed, which gives me concrete grade wise, steel grade wise shuttering. It gives me quantity, rate, the total cost. So element wise cost and total cost. And also if I scroll down, it will give me some design metrics. So it will give me some consumption to concrete ratio, steel to concrete, steel to plan area, percentage of various grades of steel, etc. So some information which are MIS information helps the management better understand the design output. Then I can go in and generate another output which is, as we mentioned, the reinforcement type wise report. When we do that, it will give you how much is reinforcement, is main reinforcement, how much is links, how much is face, reinforcement, etc. And finally, it gives me a total of all of it at all levels. So it helps the user understand component wise where is the reinforcement. And then we go into a level wise and dia wise where you can get an information at each level, understanding the diameter, which diameter, what is the consumption. And finally, if you go down, you get a table which gives you a summation of all the outputs. So you get diameter wise total output of each and every column, which can be used for procurement. So you can either do stage wise procurement, so level by level, or you can look at a total value. So both those information are available to the user. So this is a detailed level wise and dia wise BOQ output. This in a nutshell comprises all the BOQ outputs and all the output that RCDC gives. So as you see, we have imported data from columns from the analysis file. We have quickly designed, we have detailed, and then gone on to generate all the possible outputs. So CAD outputs, drawings, the design calculation reports, BOQs, the whole lot. So